Hi Yr8, this is a lesson on exercise 4E, dividing algebraic terms. So we're going to look at expanding where appropriate to find common factors and then look for any numbers and pronumerals that cancel out to simplify. So we're going to just go through some key ideas. Division problems that contain algebraic terms. Okay, the best way to work with these is to write them as fractions. Okay, so we look for some things to help us simplify. So the first thing we look for is any common factors. Could be numbers or pronumerals or both in the same question. And we look at the numerator and the denominator to see where we have anything that's common. The second thing we look at is if we can cancel out by dividing by the highest common factor for the numbers or the pronumerals or both. And 3, then we complete our question by writing in simplest form. So here is an example just following this three-step process. So we have 12AB over 9AD. Okay, this is the same as writing it like this, but again, coming back to this first statement, prefer that it's worked with as a fraction. And then they've written in expanded form to just separate each letter and number, so you can see it a little bit more clearly. And then they've gone and looked at where we can cancel out. So if we look at the two numbers, 12 and 9, we think about the highest common factor. In this case, it's 3. So if we divide 3 into 9, we're left with 3. If we divide 3 into 12, we're left with 4. So the numbers are sorted. We have an A as in the numerator and an A in the denominator. We can cancel them out. Okay, so put a cross through them. And B and D, well, we can't cancel those out because they are different letters. So what we're left with as our final answer is a 4 and a B in the numerator and the 3 and the D in the denominator. And that's our final answer. We cannot simplify that any further. And this is just to note that A over A, okay, that cancelled out. It cancels out to 1, but we know that if we put a times 1, okay, in our numerator here, it won't make any difference to the answer. All right, so let's have a look at some more examples where we are writing in expanded form and then simplifying. So we've got 2 questions and there's 3 parts to each of these questions. Okay, so I just want you to do things in 3 steps. So the first one, it says to write the numerator and the denominator in expanded form. Then part 2 of the question says to identify any common factors. And then part 3 says to simplify. So our first question is 8x divided by x. If we bring up our solution, part 1 of the question says to write in expanded form. So what that means is we're going to write with the inclusion of multiplication sign. So here we can split up the 8x into 8 times x. And then that's over, well, we've just got an x down the bottom. We can't write that out in expanded form any more than just simply writing x. Okay. Part 2 is, well, what is the common factor? So we look at the numerator and the denominator. They both share the letter x. So we write that as our common factor. And part 3 is to simplify. Okay, x over x, that's the same pronumeral. They can cancel out, okay, and they end up with 1. So they've shown that as 1 over 1, and we know that 8 times 1 is 8, and dividing 8 by 1 is still 8. If we look at question B, we have 4mn divided by 10n. If we follow our process here, first by writing it in expanded form, so 4 times m times n over 10 times n, just putting in the multiplication signs. Then we look for common factors. I definitely know they share an n, and I look at the numbers 4 and 10 and think about what numbers divide into both 4 and 10, and the highest is 2. Okay, so I write out both of those common factors. The last part is now we're going to simplify. We can cancel out the n's. Okay, we can divide both 4 and 10 by 2, so we've got 5 in the denominator, 2 in the numerator. This m here is just on its own, doesn't share anything in common with anything else, so it stays there. So I'm left with now 2 times m times 1 over 5 times 1, and then break that down again, get rid of the multiplication signs, we're left with 2m over 5. Okay, let's have a look at example that looks like it doesn't look like a fraction, I should say. So we're still going to follow the same process. We're going to rewrite this question as a fraction first. Okay, we split it up in expanded form by putting in our multiplication signs, and then we look for any common factors. So we know the a's can cancel out. Again, we get the same thing here, 1 over 1, and then simplify all of that. We're left with just 7b. Part 2 is looking at simplifying algebraic terms. Okay, so here's a key idea statement. Writing algebraic terms in expanded form can help identify common factors. Well, we've already been doing that. Okay, so here's a question that looks maybe a little bit more complex. I'm still going to follow the same process. Okay, it just looks like a bit of a longer question. Okay, given that there is more terms to deal with. Okay, so, well, not more terms, sorry, more individual components of the term. So if we write it out in expanded form by putting in our multiplication signs, then we look for the common factors. Okay, if we look at the letters, I don't have any other A's except for this A here. I've got these 2 B's here which can cancel, and I've got these 2 C's here which can cancel, and this letter D is also just on its own. Then I look at the numbers, 15 and 25. Okay, if you look at the thinking notes here, highest common factor is 5, so we can divide both by 5, and we're left with 3 at the top and 5 at the bottom. Rewrite this step now in its simplest form, and then we can, oh, they've actually made a mistake there. That, guys, should actually no longer, well, they've already cancelled this out, so they shouldn't really be showing. These should all be 1s. 1, 1, 1. There you go, there's a mistake in your textbook. Alright, so they should all be 1s. They are all going to disappear, and we're left with 3a over 5d. Alright, now we're going to use an index law. Alright, so I showed you an index law in exercise 4D. And that was the first index law. Now we're going to look at using the second index law. Now you can see that we're dividing here, and in our first index law we were multiplying. Now in the first index law we were multiplying and then we added the powers. Now we're going to be doing the opposite. We're dividing, so now we're going to subtract the powers. So if I'm going to just write you the rule for the second index law, I'll write it over here. Try and do this as neatly as I can. Oops. Okay, second index law. If we have a to the power of m divided by a to the power of n. That equals to a to the power of m minus n. Okay, you can write that rule in your summary books. And now let's have a look at our solution. Okay, well, both solutions are here. So if we look at the first question, the base, which is x in this case, all right, doesn't always have to be a, this is just your rule. X stays the same, and we do 9 take 3 to give us 6. Okay, nice and easy. Question B, well, we've got this 5 out the front. We don't have a number out the front here, but by now, hopefully, you should know that that's a 1. So I'm essentially doing 5 divide 1, which is still 5. And then I need to use my second index law here, leave the k as it is. 11 takes 7 is 4. Get rid of the times sign. Just put it together as 5k to the power of 4. Last part to this, okay, is essentially doing what we just did before, okay, but now may involve a little bit more or more steps. Okay, so if we're going to use our second index law, okay, for this question here to simplify, we can see that we can do 6 divide 2, all right, which we know is 3. Okay, they've just written this in expanded form by putting the times signs in again. And then we know that a to the power of 8 divided by a to the power of 3. Leave the a the same. 8 take away 3 is 5. And then get rid of the multiplication sign and write it like so. The last one at the top, that looks like the first index law. So that's going back to exercise 4D. And then once you simplify that, it becomes a second index law. So you're actually doing a combination of the two. So this is what it says here in step 1. So first we're going to add the powers because we're multiplying the base. We're multiplying here. So 4 plus 6 gives 10. And then we divide. And then we end up with 10 take away 7 to give us 3.